All right, we're going to be going over the chapter 3 stuff. So it's basically just about factoring. So chapter 3.1, which is basic factoring, which hopefully is review. And then 3.2, which is factoring equations, which is very similar. It just has one extra step. So let's go through the different types of factoring. I'm going to do one example of each. There's obviously a lot of questions you can do for this. So most of the stuff that you've been doing is distributing and expanding and simplifying questions. That's when you get stuff that looks like this. And you say, oh, well, I know I got to distribute the 3, so I make it 3x plus 6. Okay, that's simplifying. That's what you do in most questions. Factoring is when you do the reverse, when you turn it from the simplified version into this, so it's factored. So you have stuff, usually stuff outside coefficients, or you're going to end up with stuff that will look like this, that kind of thing. That's factoring, when you're trying to break it down into pieces, essentially. So I'm going to show you the different types of factoring. The most important is common factoring. You always, in every single question when it asks you to factor, common factor first. So common factoring is when you look at all the terms, 2, 3, 5, it doesn't matter, and you say, what do they all have in common? So what is the greatest common factor with these? Well, I know there's a 2, because 2 fits into 4 and 2 fits into 2. And I also know they both have an x. So I'm going to make 2x what I factor out. Then what I'm going to do is I'm going to write in brackets what the two terms will become when they're divided by 2x. So 4x squared divided by 2x leaves me with 2x. 2x divided by 2x leaves me with a 1, and there's still that plus in the middle. If you wanted to check to make sure your answer was right, you could use distributive property, rainbows, and check to make sure that it gives you the right answer, and it does. That's it. You just need to find what that common factor is and pull it out. Difference of squares. Oh, this is the stuff we're going to be doing today. Difference of squares. They're always going to be a binomial. So if you have a trinomial, like these ones down at the bottom, we're not going to do those. Okay, those are a different way. The other thing is it has to be a difference. It has to be subtraction. If it's the same exact thing added, it doesn't work. Okay, so your trick is if you ever see a binomial and it asks you to factor, first of all, there's probably common factoring. But second of all, you're probably going to be doing a difference of squares, especially if there's negative. So what we're going to do for difference of squares, it always looks like this. There's always going to be the two, the factored into the two brackets multiplied together. And we're going to find the square root of term A and the square root of term B. And when I say A and B, I mean this one and this one. So this one, this first term, the yellow one, square root of that is going to be 2x. 2x. For the second one, square root of 16 is going to be 4. So we write the square root of the first one and there, and the square root of the second one there. Then the only thing you do is you write plus for the first term and minus for the second term. That's how it always works. It's always going to be plus, minus. You can write the minus first if you want. It doesn't really make a difference. And the reason this works is because when we multiply this out, the middle terms are going to actually cancel each other out. I'll show you what I mean. So if we did this, well, these multiply together, 4x squared, and then minus 8x plus 8x minus 16. So what you're going to notice is that these two cancel each other out, and you're just left with 4x squared minus 16. So that's actually the same. So the idea is, what I want you to take away is that when you get a difference of squares, whereas a square minus another square, it turns into this. Be careful, because you're going to get weird trick questions where it says stuff like this. Is that a square? Yes, it is. Is that a square? Yes, it is. Okay, so just be careful, but a lot of times if there's two terms, there's difference of squares. And a lot of times there's tricky questions where it ends up being difference of squares and students don't see it. So always have this in the back of your mind. Factor by grouping doesn't actually happen very often. The clue is when there's like 4+ terms. I would try and common factor first, but you got a 3, 2, and it doesn't work. So factor by grouping is when you common factor, but only 2 at a time. So I'm going to common factor those first two. We got 3x, so it's going to give me x plus 2. And then the second two terms, I got a 4, gives me x plus 2. You're going to notice that this works if what you factored for both was it ends up actually being the same, like in the brackets there. Then what we're going to do is we're going to factor again. essentially think of it like this. This is now one term, and this is one term. This is kind of like the first one's 3x a, and the second one's 4a. They both have the same thing we can factor out, this a thing, which is x plus 2. So we're going to factor it for both of them. So I'm going to factor x plus 2, and it's going to leave me with the 3x plus 4. These two became these two. And that's it. That's factor by grouping. So we went through, we put the first two together and factored them, common factor, second two common factored, and then we took the same terms here, factored them, factored down to there, and then whatever was left over, those two things became this part. I know it looks kind of weird, a couple practice questions and you'll get it. All right, trinomials. This is the most common and the most important, and frankly the hardest until we get to difficult trinomials, but the same basic principle. What we're going to do with difficult trinomials and trinomials is, again, it's going to turn into this, where we're going to have something like x plus 1 plus 2, something like that. But you need to figure out how we can actually get these parts. The rule is, we look at this last term. Give me one sec. The rule is, we look at the last term and we try and find out what multiplies to this. And we need to look at this middle term and figure out what adds to this. So what I always like to do is on the side, I write the number I have, 6, and I need to write out the factors. So I'm going to say, okay, 1 times 6, 2 times 3. That's it. I usually go by numbers 1, 2, 4, 5, anything that fits. And then once you start getting to numbers and start looping around, you know you're done. So now I need to look at these pairs, so either 1 and 6 or 2 and 3, and figure out which one's going to add to 5. Well, the answer is obviously this one, 2 and 3. So what we're going to do is, it's really simple. I'm going to write x and x because x squared means x times x. These two numbers right here, I'm going to put them here, and that's it. There will be times where you're going to have to maybe make this a negative. So for example, if it was a -6, then I would have to think, okay, well, one of these terms is going to have to be negative. Like maybe I need -2, or maybe I need to have -3, or maybe I need both of them to be negative. Think about that carefully when you're doing the questions. All right, difficult trinomials. Works the same way. The reason these are hard is because there's a coefficient that is greater than 1 for the a term. So what we're going to do, there's like a trick. The kind of slow strategy is to try and guess and check by just subbing in like random numbers for your first term like this. But this is going to take a long time. There's like a faster method that we're going to do. You actually write out the factors of AC. So whatever your a term was multiplied by your c term. So in this case, 6 times -2, let's do that properly, 6 times -2 equals -12. So I'm going to have to write out my factors for -12. So I got 1 and 12, 2 and 6, 3 and 4, my bad, and I think that's it. Yep, okay. I don't like writing in the negatives yet. I like just putting these first, and now I got to figure out, okay, what's going to multiply or add to give me -1. So looking at these, I know it's not 1 and 2, 12. I know it's not 2 and 6. It's going to be 3 and 4 because there's a difference of 1 between them. So I want these two to add together to be -1, so I need to have 3 minus 4. So it's going to be +3 and -4. What we're going to do, what we are not going to do is what we did last time, like this. We're not simply going to sub the numbers in. The reason this doesn't work is because if I did x times x, it doesn't give me the 6x squared I need. We're actually going to do a middle step. What we're going to do is we're going to rewrite the question. These first two terms, the first term and the last term, are going to stay the same. The middle term, we're actually going to split into two pieces. It's going to be plus 3x minus 4x. We took these two numbers and we put them here as their coefficients. And the idea is that if you did 3x minus 4x, it gives you that -x. Now what we're going to do is factor by grouping. That's why we learned it. So we take these first two terms. What do they have in common? Well, they both have 3x. And that's going to be 2x plus 1. And then what do these two have in common? -2 gives me 2x plus 1. If I had taken out, let's say, a +2 instead, I would actually have this, -2x minus 1. I need to make sure that these two terms, these two things in the brackets, are the exact same. They aren't the same, so I would need to take out the negative like I did originally. Bam. Fixed. Yeah, good. You know you did the factoring correctly if these two things in the brackets are exactly the same. Now we'll factor it like we did before. And that's it. We got our final answer. Be careful about that negative thing there, because that's what messes up a lot of students and is tricky about weird questions. That's basically it. Factoring the fractions. If you try to factor this the way that we did these questions, you're going to get messed up. It's going to be really hard. So what you're going to do is you're actually going to factor out the fraction to make your life easier. So looking at this, they both have a quarter. So I'm actually going to write 1/4 and rewrite the entire equation as if they needed to be multiplied by a quarter. So this is going to become 1x squared. This is going to be negative 3x. And this is going to be 28. Now, I always find it helps to double check this because this is where students make a lot of mistakes. So you just think, okay, wait, 1 times a quarter? Yeah, that gives me a quarter. Negative 3 times a quarter? Yeah, that gives me 3/4. Negative 28 times a quarter? Yeah, that gives me negative 7. Good, I did this properly. Now, we're not done. We're going to factor this like a normal trinomial like we did in all the other questions. So I got to do my negative 28, write out my factors. 1 and 28, 2 and 14, 3 doesn't work, 4 is going to be 7, 5 doesn't work, 6 will work. Nope, sorry, 6 won't work. So that's it. So I got to figure out which one's going to be. Oops. It's going to be the one that gives me negative 3. So I'm going to look at 4 and 7. It's going to have to be negative 7. So I'm going to write out the 1/4. And it's going to be x plus 4, x minus 7. And we're done. So you'll find that this part works the same and easy. You just had to take out that quarter at the start. So don't freak out when you see fractions, just get rid of them by factoring. The exact same thing is going to happen with decimals. Again, we're going to factor by decimal. Some questions you're going to have to factor by like 0.1 and that'll work. Some questions like this one, I think 0.5 would be even easier. I'm going to do 0.1 because it always works because you have only one decimal place, and then we'll just have to factor again. So I'm going to factor out the 0.1. This is going to give me 10x squared plus 25x minus 15. I'm going to double check to make sure I did it right. Yep. And now, before I keep going, I'm going to common factor. It looks like common factor is going to be 5. So I'm going to factor out common factor of 5. So it's going to be 0.1 times 5 times 2x squared plus 5x minus 3. And remember, this 0.1, again, students make a mistake here. This is actually going to turn into 0.5. Okay? Be very careful. A lot of students will just write the 5 and forget that there was a 0.1 originally. Don't do that. Okay? The coefficients get multiplied together. So now we have a difficult trinomial. Let's do it the way we normally do it. I need to do negative 6. It's actually the same as the other question was. So it's going to be 2 and 3. It's going to be negative 2 and negative 3. No. Come on, Mr. K. It's going to be negative 1 and positive 6. So we're going to do 0.5, 2x squared minus 1x plus 6x minus 3, 0.5. This is going to give me x 2 minus 1 plus 3 x there. 3, 2x minus 1. So we're going to get 0.5, 2x minus 1 times x plus 3. Cool, done. So again, the decimal works the exact same way as the fraction. Be careful with the stupid, difficult trinomials because it can get a little messy as we saw here with what I was doing, but that's basically it. Now, 3.2 works the exact same way, but the only difference is whenever we're doing equations, we actually want to find out what is x equal to. What I'm going to tell you is that when you have a square, when you have an exponent like that, x is going to equal the two numbers. There's going to be two answers, or in the rare case, there will be one answer twice. I'm going to show you what I mean by that. So the very first thing we want to do, we want to make it so that we can factor. Next video, I'm going to go over some more difficult questions about this. But basically, I look at this. I'm going to try and factor it the best I can. The easiest way to do this is going to make a trinomial. So let's go 3x squared minus 4x minus 7 equals 0. I now have my trinomial, which I'm going to factor like I normally would. So I got 3 times 7 gives me negative 21. Let's write out the factors of that. I think that's it. Yeah. So it's going to be negative 7, positive 3. 3x squared. Oh, let's do black. 3x squared plus 3x minus 7x minus 7 equals 0. Factor by grouping. 3x. X plus 1 minus 7. X plus 1. Careful with that double negative. Equals 0. 3x minus 7 all in a bracket. X plus 1 equals 0. All right. So this is the part where you should have been able to do by now. And what the difficult part of this question now is finding what x is. So what we're going to do is we're going to actually isolate. If I had a question like this, 3x equals 0, what would you do? Well, you know you'd have to isolate the 3 by dividing it away. When you divide 0 by anything, it still stays 0. So we're going to do the exact same thing here, except instead of dividing by that 3, we're actually going to divide by this entire thing in the bracket, 3x minus 7. Okay, so it's going to cancel out, and we're going to get x plus 1 equals 0, or x equals negative 1. Now, because we did that and we canceled out this one, we need to do it again, but instead cancel out this one. So I'm going to write it again so we can see it. I'm going to divide by x plus 1 on both sides. Cancels out. And then just solve. Yay. So what you will see is that we had two answers in the end. X is equal to negative 1 and x is equal to 7 over 3. Those are the two answers that if you subbed into the equation, it would actually equal to 0, it would work. When we get into graphing next unit, we'll be able to understand and see this more clearly about parabolas and stuff. I'm not going to go into that right now. It's really complicated. But there are two answers because x had a exponent of 2 in it. I want to show you also a really quick way to deal with this type of question. Sorry, this is kind of running long. When we got to the end, we got 3x minus 7, x plus 1 equals 0. You can do it the way I did it, where we did all these steps. It took a lot of space and a lot of time. But once you see the pattern, it's pretty clear. I know the answers looking at this. This is going to be x is equal to negative 1, because I can just do the substitution and the solution in my head. And I know this is going to end up giving me x is equal to 7 over 3. Once you're able to do that by just doing the math mentally in your head, make sure your teacher's okay with it, and then you're able to get these answers really, really quickly. And that's basically it. That's all we wanted to cover for today. Yeah.